Hello my dear friends, welcome to the class 12 English medium for the subject of statistics, part 2, chapter 4, that is limit. Today we will be discussing some other concepts related to limit and related to function. Now, two of the basic terms which we are going to study here. As you can see the line, we call it the real line R. That means any value which belongs to this infinite line is a real number and we call this line a real line. Now, any two values, let's take A and B. So the distance or any values which are the part between these two values A and B, we call them interval. That is, all the values are the part of the interval A and B. So on this real line, all the values which are part of A and B and the distance between them two is known as interval. Now there are four distinct types of intervals. First type is a closed interval. Here closed interval means that all the values between A, B and A and B themselves, we can denote them by this. As you can see, I have used here the square brackets, or we can also call them the box brackets here. So box brackets A and B means that the value variable x lies between A and B, and it also includes the value A and the value B. Therefore I have written A less than equal to x less than equal to B. That means x is equal to A, x is equal to B, and x is all the values between A and B. The second type is the open interval. Open interval, we use simple brackets or the braces. Here all the values between A and B are the parts of x, but A and B are not part of x. Therefore I have written A less than x, not equal to. That means x is not A, x is not B, but x is all the values between A and B. So that's a open interval. So closed interval includes A and B, open interval excludes A and B. So we have some combination for that. Closed open interval. Here A is the starting point, B is the ending point. So A is closed while B is open. We can denote it like this. See the pattern of brackets here. I have used closed box bracket for A and simple bracket for B. That means x is equal to A but x is not equal to B. So at the A point x is closed, but at the B point x is open. Just pay attention to the signs I have used here. Then comes open closed interval. That means A is open but B is closed. Once again, check the pattern of brackets I have used. A is a simple bracket, B is a box bracket. A is not equal to x but B is equal to x. That means x is a set of all the values between A and B but not A. So these are the four types of intervals which we should remember for our further studies. Now, there are three important forms of functions which we are going to study for this chapter. The first one is the modulus form, second one is the interval form, and third one is the neighborhood form. Now, modulus is written like this, that when we say the x modulus, it means x can be positive, x can be negative, or x can be 0. So x modulus is either more than equal to 0 or it is less than 0. Both are possible. Now whenever we are writing modulus form for the limit, we are writing it like this. Modulus x minus a is less than delta. This is the modulus form for the limit. Now here there are two constants, a and delta. A is a simple constant value and delta is the distance between x and a. That means the difference between x and a is denoted by delta. So x minus a modulus is less than equal to delta is the modulus form for the limit. So remember this highlighted form. Okay, interval form. Now in the interval form we are going to use the same a and delta. Here we know that if x is more than equal to a, there are only two options. Because it's a modulus, there are only two options possible. Either x is more than a or x is less than a. Now if we assume that x is more than a, then x minus a is less than delta, naturally, because that's our modulus form. So if x minus a is less than delta, then we can change the side of a to get x is less than a plus delta. The last part I have written here, x is less than a plus delta. Inversely, if we assume that x is less than a, then we have to say that a is greater than x. So a minus x should be less than delta. As we know that x minus a was given in modulus, it could be either x could be greater than a, x could be less than a. So if x is less than a, then a minus x is less than delta. And when we change the side of x and delta with themselves, we get x is greater than a minus delta. So if you take the last two answers, x less than a plus delta, x greater than a minus delta, we get something like this, that x lies between a minus delta and a plus delta. So these are the two interval points for x. So whenever we talk about limit and forms of functions for this, using a and delta, x lies between a minus delta, a plus delta. So these are the two intervals. I showed you that interval was depicted by a and b. So right now we will just replace those a and b with a minus delta and a plus delta. Simple, right? Remember this. Okay, last one is the neighborhood. Usually an open interval with a, where a belongs to the R set, is called neighborhood of a. Means any open interval with which contains a in it is called neighborhood of a. Okay, that's simple. Now the open interval which was given in the interval form is called delta neighborhood of a. Okay, it's a special neighborhood of a. Why? Because it uses delta, because the difference of a is shown by delta, a plus delta and a minus delta. So that is called delta neighborhood of a. So for using that in our limit, symbolically we write it as n a delta. What we will call it? Delta neighborhood of a as n brackets a delta. And if we are going to write it in our curly brackets form, it becomes x, where modulus x minus a less than delta, x belongs to R. So as you can see, the modulus form, interval form and the neighborhood form, all these three forms are connected one by one. Something is similar between all of these three forms. In all these three forms, I have highlighted a certain portion, and that portion is the actual form. That is, modulus form will be x minus a modulus less than delta. Interval form will be a minus delta, a plus delta. Neighborhood will be n a delta. Okay. We will summarize it in short, that delta neighborhood of A can be expressed in one of the following three forms. The first form is the neighborhood form, where it becomes n a delta. The second form is the modulus form, where it becomes modulus x minus a less than equal to delta. And the third form is the interval form, where it becomes a minus delta, a plus delta. So these are the three forms which we are going to discuss in the following tutorial. We will start with illustration. Illustration 1. Express n phi 0.2 in modulus and interval forms. Okay. Now when we compare the NA delta, that is neighborhood form, with the given value n phi 0.2, we can understand that A is equal to phi and delta is equal to 0.2. We are just comparing the forms and getting the values of our constants. Now as we know that A is 0 phi and delta is 0.2, we will start by writing down the modulus form. Our modulus form here is x minus a modulus less than delta is equal to, we will replace a with 5 and delta with 0.2. So this is what we will get, x minus 5 modulus less than equal to 0.2. So that's the modulus form for the given question. Okay, so question wise the answers will change, but the format, the form will be same. Next is the interval form. Now we know that interval form is a minus delta, a plus delta. So we will replace a and delta with 5 and 0.2 like this. Adding and subtracting, we will get 4.8 and 5.2. That means the interval for the current variable is 4.8 to 5.2. The maximum value is 5.2 and the minimum value is 4.8. So variable x lies between 4.8 and 5.2. It's very simple. Next is illustration 2. Now we have to express 0.001 neighborhood of 3 in modulus and interval form. Okay, first of all we have to understand this. We will compare 0.001 neighborhood of 3 with delta neighborhood of A. Okay, so as we know the delta and A, the delta will be 0.001 and A will be 3. Now what we have to do, we have to put delta and A into modulus and interval forms. We will start with the modulus form. Putting A and delta, we will get x minus 3 modulus less than equal to 0.001. Similarly, if we put it in the interval form, that is A minus delta A plus delta, we will get 3 minus 0.001, 3 plus 0.001. That means 2.999 and 3.001. So that's the limit, or that's the intervals for the given question. Okay, now we have another question here. In the question itself, we have the modulus form. See, the question itself given is in modulus form and we have to write it down in the neighborhood and interval formats. First, we are going to compare x plus 1 less than 0.5 with our modulus format of x minus a modulus less than delta. Now, here a should be negative while in the question it is plus 1. So, we have to change the sign. So what we can get is a will be negative 1 and delta will be 0.5. Once again I will repeat that x minus a is given and x plus 1 is given. So we have to change the sign. 1 will be negative 1. When we convert this into our neighborhood format, n a delta will become n negative 1 0.5. That's all. We don't have to calculate anything. We just have to show them in a particular format. Next is the interval form. In the interval form, we already know a minus delta, a plus delta becomes negative 1, negative 0.5, negative 1 plus 0.5. Will give us the answer negative 1.5 minus 0.5. So the intervals here are negative 1.5 to negative 0.5. That's all, my dear students. This is very easy. Okay. Let's take one more last example. Express 0.9 and 1.1 in neighborhood and modulus form. Now we know that there are three forms available: neighborhood, modulus and interval. As we are already supposed to find neighborhood and modulus, naturally the given question is in the interval format. Now our interval format, when we compare 0.9 with 1.1, the interval form is a minus delta a plus delta. So 0.9 will become a minus delta and 1.1 will become a plus delta. Now in the primary standards you have studied the method of addition of the two functions a minus delta and a plus delta. When we add both of them, the delta gets eliminated. So a plus a becomes 2a and 0.9 plus 1.1 becomes 2. So 2a is equal to 2. That means we can get a is equal to 1. Now this calculation you must do in your paper because this is something you have already studied in your primary standards. Still I am giving you the concept here. You should try it. Next, when we put the value of a into a plus delta 1.1, we can get delta is equal to 0.1. Means in the place of a, you should put 1, then change the side of 1 to the opposite. 1.1 minus 1 will be 0.1. So here a is 1, delta is 0.1. What we are going to do? We are going to put these two values into neighborhood and modulus form. Neighborhood form here will be a delta, that is 1 and 0.1, whereas the modulus form, as we know, will be x minus 1 less than equal to 0.1. These are very simple sums. Now let us understand one last concept before completing our today's. That would be punctured delta neighborhood of A. Okay, delta neighborhood of A we already know, but the punctured delta neighborhood of A has something additional. If A belongs to R and delta is a non-negative number, then the open interval A minus delta, A plus delta minus A. Okay, what I am doing here, A minus delta, A plus delta minus A is called punctured delta neighborhood of A. That means from the intervals A minus delta to A plus delta, we are removing a one element, that is A. It is denoted by n star A delta. The delta neighborhood of A is denoted by n A delta. Punctured delta neighborhood of A is denoted by n star A delta. Let us check it out symbolically. N star A delta is equal to n A delta minus n. Now that means that value of A is to be excluded from the whole interval. So we are going to write it into our symbols, that is x, where A minus delta less than x less than A plus delta, where x is not equal to a, that means a is not part of x and a belongs to r. Also when we simplify it, it becomes x, where modulus x minus a is less than equal to delta, but x is not equal to a and x belongs to r. So that way, my dear students, we have studied some basic concepts and terms for this chapter. This is something very easy. We are just supposed to convert the given format into remaining two formats. Only three forms are there: the modulus form, the interval form, and the neighborhood form. And these are actually very easy. Revise this tutorial 1 to 2 times if you feel like it, and try to complete the exercise 4.1 given after the illustrations of this tutorial. If possible, try to do it on your own. In a short time I will be publishing its answers. So till then, see you dear students, have fun, stay home and stay safe.